Good morning, everyone. My name is Greg Aranda with Graybar. I'd like to welcome you to Graybar's G2 Talk presentation on Don't Be Left in the Dark, 3 of the biggest misconceptions about outdoor LED lighting and how to overcome them. This talk is part of a webinar series we offer each month for our customers. We have a great discussion lined up for you today, but before we get started, I'd just like to cover a couple housekeeping items. First of all, if you are one of the first 50 people to join the presentation, you'll receive a coupon for a free cup of coffee, courtesy of Graybar, as a thank you for your time today. Also, at the bottom of your screen, you'll see a box for Q&A. Feel free to submit questions throughout the presentation, and we'll address as many questions as time permits at the end. Lastly, our G2 talks are all archived on graybar.com. You'll be able to view this presentation again or recommend it to others. We're happy today to team up with Acuity Brands. As an electrical distributor, Graybar works alongside Acuity Brands to offer innovative technology and an extensive portfolio of products to deliver a cost-effective, safe, and productive healthcare environment. You can visit graybar.com to learn more about our solutions. At this time, I'm happy to introduce today's speaker, Karen Gale from Acuity Brands. Karen is Vice President of Healthcare at Acuity Brands Lighting, one of the world's leading lighting, controls, and day lighting manufacturers. With more than 16 years of experience in the lighting industry, she's keenly focused on understanding and improving the visual experience of those in the healthcare industry in a sustainable and energy-efficient manner. Throughout the past few years, Karen has conducted educational presentations, workshops, focus groups, and in-depth seminars on lighting and controls design for healthcare facilities to thousands of participants across North America. She has an MBA in International Business and a BBA in Marketing from Georgia State University. So without further delay, I'd like to turn it over to Karen. Take it away, Karen.
Thank you so much, Greg. So Greg made me sound kind of awesome and slightly old. 16 years is a long time to be in the lighting industry, but that's okay. I love it. Obsessed with it. And thank you for everybody that's out there in the webinar universe for signing up for this talk. So as Greg indicated, the whole focus of this talk is really around outdoor lighting. And Don't Be in the Dark is really sort of focused on, what happens when the lights are out and exterior lighting. And many of the folks on this call have heard about LED lighting for some time, have probably evaluated outdoor LED lighting, but since so much has changed, even in the last 6 to 18 months, we wanted to touch on 3 of the biggest misconceptions that we see in outdoor LED lighting and how you, as practitioners, can overcome them. So just to kind of lead things off, here's some observations that kind of we see, and you may be seeing sort of a similar thing. Certainly LED lighting has become the predominant source for new outdoor installations. It is unicorn rare to see a new specification where you wouldn't have LED lighting specified in the exterior. And why is that? Well, there's no source on the market right now that has a better combination of efficiency from an energy perspective, longevity, really super long lifetimes, and performance. So you kind of have that trifecta, so you're certainly seeing LED in those spaces. However, when you look at existing spaces, so if you're a stalker like me and you drive around and you look at the lighting in parking garages and lots and building facades, you still see a lot of legacy, kind of what we would call traditional sources like HID. And so when you look at the overall installed base of many of your campuses or the campuses in your communities, the percent conversion to LED is relatively low. We estimate less than 5%. And then, when you look at the healthcare, and much of what I'll talk about today will be focused on healthcare. If you don't focus on healthcare, you'll still get some good tools and tricks to help you. But when you look at facility managers in healthcare settings who are among the busiest people in the world, they're still maintaining, in many cases, really inefficient, high-maintenance fixtures, the prima donnas of lighting fixtures, because older technology is really hard to maintain. And so why is that? The other thing that just kind of we see in our observations is that there is not a deep understanding of how lighting can impact broader objectives that health providers have. And so that's really the intent of this talk, to kind of really break down some of those factors and say, okay, look, how can we overcome them? So before we jump into that, I'm going to give a little bit of background on what's happening in healthcare, why healthcare is really a very key market and industry for these types of upgrades, because it's essentially a perfect storm when you look at all the factors that are facing healthcare providers. So a couple of different things. Unprecedented policy and demographic changes, as well as fiscal challenges. So in the United States, we have new Patient Protection and Affordable Care Act, newish, which is increasing coverage and access. So what that means is more patients. In addition to that, there's fiscal challenges. So costs of care are going up, so reimbursements in many cases are going down, and so the whole fiscal and economic health of a facility is something that we really have to bear in mind. Aging population, that creates different visual needs. It also has created more demand for care, particularly in places that have larger percentage of older adults. And all that's really interesting, but at the end of the day, it's really around improving the quality of care delivered, and that means outcomes, that means experience and comfort, and we will touch on those themes, and also safety, which we will touch on. So keep that in mind, experience, comfort, safety, we'll revisit that. If I really want to illustrate, and healthcare is more than just hospitals, but if I take hospitals, for example, every dollar counts. Everybody's margin constrained. So if you look at this hospital breakdown that comes from American Health Association data, we've got not-for-profits and for-profits. A typical not-for-profit hospital has an operating margin of only about 2%. So $1 on the bottom line is equal to 50 on the top line. So when we talk about energy savings, for example, just to use a non-for-profit world, we don't take it lightly because we know that there's not a ton that's trickling through. So anything we can do to save $1, we're going to do that. Moving forward as well, it will come as no surprise to anybody that healthcare facilities are very energy intensive. Certainly the inpatient world that is 24/7 is very energy intensive, and lighting is kind of a big deal in a healthcare facility. Everybody would agree. But when you look at even urgent care, medical office buildings, facilities with extended hours, long-term care, you can see why the energy intensity is there. When you look at DOE data, and this is really the proportion of electricity that's used, lighting comprises between 40 and 42% of the electrical use in a typical healthcare facility. This number certainly varies by facility depending on what's happening with the HVAC, but it's still a major chunk, and there's still a lot of low-hanging fruit out there, which is kind of interesting to see. We also talked a little bit about experience, but to expound on it a little bit more, experience really matters for patients. We have patient perception surveys that are mandatory in some types of care, like acute care, and anxious visitors that are supporting patients, but also staff. The facility is a very important tool in things like staff recruitment, staff retention. There are lots of trends where physicians are becoming employees of hospitals. We know we have nurse shortages, so the built environment really does help communicate and increase the perception of quality when we do that right. So, given that we have kind of talked about some of the major trends, I'll illustrate a little bit more. Exterior lighting is often the first impression, and it's the last impression, and it's the lasting impression, just to sort of take that a bit further, and it really matters. I found this study about seniors, age 65 and up, that said parking ranks second only behind the lobby as factors that impact the first impression of a hospital. Everybody's had a nightmare experience trying to park in a hospital, and reduced visibility, areas that don't feel safe and secure, that detracts from the experience. I also included a quote from John D'Angelo in Supai when John was at New York Presbyterian around creating a sense of security. So hospitals can create an oasis of safety and a clear line of demarcation for patients entering their campus. Oasis of safety sounds awesome, does it not? But it really does kind of give you that first impression as well as the last. So that's really important. So let's delve into kind of the nighttime environment and spend some time on the different misconceptions here. So the first one that we want to spend time on is this idea of where our focus is. So I've called this, it's what's inside that counts. Well, what does that mean? That's really vague, Karen. What do you mean by that? Well, you know, a lot of times when we're thinking about relight, we go right into, we walk right by, right through the garage, right through the parking lot, right through the lobby, and we start thinking about, okay, how can I save some energy? And what we've done is effectively walked right past lots of opportunity. That's easier to get to sometimes than relighting interior areas of our campus. We know in a healthcare facility, even though there's miles of square footage in many cases, it's not always the easiest thing to go in and do a full-scale relight project in the interior of a building because it can be potentially disruptive. We certainly have more flexibility in outpatient facilities that actually close, but in hospitals it's a little bit challenging. You kind of have to do it when you can. So while we love facility interiors and we love facility relight, it's time to really think again about outdoor if you really haven't touched it yet, because that's your low-hanging fruit. Couple of things, a couple of reasons I think why people maybe didn't really address all the exterior opportunity, and a lot of it is because, you know, the situation has changed. So we know that in outdoor lighting you certainly have long burn hours, so 24 hours a day for parking garages, which are pretty much always lit. But even in parking lots, you're going to light it from dusk to dawn. So in the summer, you know, who knows, it could be about 9 hours. In the winter, you may be looking at 14 hours. There's still a lot of burn time. And certainly you have inefficient legacy sources, as we mentioned. Now, the early days of LED, when you looked at it and you said, look, this is Captain Obvious. I can relight this space. I want to improve my lighting. My parking garage lights are always on. You would crunch the numbers, you'd look at available products, and you would come back with a whopping 5 to 7 year payback, which I don't know about you, but that never really knocks anybody's socks off. Many facility managers, through budgeting, 5 to 7 year paybacks are just non-starters. You really have to come in lower than that for your proposal to be accepted. This has changed. A lot of it is because there are more good products available. The source technology has gotten more efficient. Price points have come down as the technology has become more pervasive. And today what we're seeing, and I'll delve into some of these examples a little bit more at the end, is we're seeing 1.5 to 2 year payback periods just on energy alone, and that's not layering in maintenance. So it's really worth another look if you've looked at it in the past, but you couldn't make the numbers work. Look at it again. Something may have changed. The other thing, you know, and I kind of mentioned this, product has advanced, technology has advanced, decreases in first cost. This next bit that I'll talk about is equivalency, so we'll spend a little bit of time on that. And then incentives have become a lot more pervasive. There are listings that we look for, like DLC, Design Lights Consortium, that unlock incentives that may have not been available when you first started looking at exterior relight. When we talk about it's what's inside that counts again, you know, a lot of times patient perception is shaped before they even enter the building. So here was a quote. The top one is a quote that I found from a wayfinding expert, where they talk about healthcare environments being large, circuitous, cluttered, alien, and non-intuitive. And wayfinding is one of those top C-level issues that you hear, right? Healthcare facilities really have a challenge with that. Outdoor lighting can help, and we can kind of talk about that. I also Googled some Yelp reviews because I'm a total stalker, right? So, and the first one was really angry, right? The visitor garage is, we'll leave that blank, on Earth. Seriously calculate 60 to 90 minutes for any visit. You know, as you go down and you look at some of the reviews that customers are, and these are reviews for healthcare facilities, they complain about garage signs not being illuminated. Parking was a bit weird. I couldn't read the signs. Somebody needs to look at the parking situation because it's very confusing, even just in the parking lot. So don't sort of underestimate the potential to really improve experience even before you get into the building. So that's really one misconception that we see. I think the second one is one that is easy for all of us to to relate to, because it's not the easiest thing to figure out what you need in terms of LED lighting in some cases. So the second misconception is that light is light regardless of the source, which is not true. You know, and this leads us to that myth of equivalency that I talked about before. So when we're looking for lighting a parking lot, for example, and we have a parking lot that uses a certain source and emits a certain amount of light on the task, we're trying to figure out, okay, well, if I'm using LED, if I'm using HID, what do I need what do I need if I'm using an LED fixture? And then if I'm comparing LED fixtures, how do I know that this person's 6,000 lumen fixture is going to perform as well as this person's 6,500 lumen fixture? So it ends up being a little bit confusing. Back in the old days, when we would specify outdoor lighting, we would talk in terms of wattage, right? So I need a 250 watt fixture or 400 watt fixture, and that's how we did it, and everybody's lamps were relatively equivalent, and it wasn't a problem. The thing is, with LED, you can't use wattage, and in some cases, lumens don't tell the entire story. So it ends up being difficult, and I kind of want to step through why it becomes difficult and maybe ways that we can help address that. Even doing a Google search of 400 watt metal halide equivalent brings up things that we just know aren't legit, to use a technical term. So for example, this particular fixture that came up is 1,400 lumens, which is essentially what a downlight would be. So we know that even when we Google something that says, look, I want something that would be equivalent to a 400 watt wall pack, we may not be getting exactly what we're supposed to get, even by looking at, sources like the internet. So how can we kind of address that? How can you kind of understand what's happening behind the scenes so that you can make more educated choices? Because clearly it's not the easiest thing in the world. Let's start with the most prevalent source that we see. Certainly we see a lot of high pressure sodium, kind of yellowish lamps, but we see a lot of metal halide HID lamps as well, kind of that whiter light. So let's start out with lumens, right? So lumens is a measure of the quantity of light that's out there. And so when you looked at a 400 watt metal halide lamp, essentially initial lumens are typically measured in the vertical position. So the initial lumens, that's the number that's the amount of light that comes out after a slight seasoning period, which sounds awesome, but it's just burning the lamp for about 100 hours. So after the seasoning, you've got initial lumens of 36,000. Now, if you're going to put that lamp, and not every lamp is rated to do that, in a horizontal orientation, you're going to lose some of that light. So you can already see that the initial lumens goes down, and it's rated for a lower level for horizontal orientation. Now, mean lumens is the number that you really almost should be looking at. Mean lumens happens, it's about 50% of rated life. So how much light would come out at 50% of the rated life? And that goes down to 22,000, right? Initial lumens. And you see that the rated life here is 15,000 hours. So let me just kind of step through that and look at it in waterfall terms. So you saw how that 36,000 lumens kind of shrunk down to 32,000, right, with the horizontal orientation. And then you saw it shrink way down. That's so much light that you're going to lose at 50% of the rated life. And then when you factor it down for luminaire efficiency, because when we report HID lumens out of the lamp or the bulb, it doesn't take into account the fact that it's going into a fixture. So if you've got a fixture that's 80% efficient or 70% efficient, you're going to lose some more of that light. And so what happens is you end up with, out of that initial 400 watt metal halide that was maybe starting at 36,000 hours, you're really ending up with 16,000 maintained delivered lumens out of that luminaire. When you look at, and over to the right, this is an LED area luminaire. You're looking at something that's starting at 21,000 lumens. You lose almost nothing because it's in the horizontal position. Mean lumens just takes into account a little bit of lumen depreciation. Because we measure delivered lumens out of the luminaire itself, you see very little on luminaire efficiency. That's really any lensing, etc. And so the difference between your initial vertical lumens at 21,000 and maintained at 21,000 is very small. Okay, so there's a lot of attrition that happens in your lumens and your legacy sources, and that's something to consider. You don't need a 36,000 lumen LED fixture, okay, if that kind of makes sense. So you see mean lumens was after 6,000 hours, and then same here after 50,000 hours. You're not losing that much light. So this is, and I'm kind of going to click through here because some of these build, but you're basically seeing, if you compare the blue, which is metal halide, if you compare kind of older LED sources, so maybe what you would have looked at when you first started looking at LED lumen depreciation versus options that are available today, you're seeing this is basically how light levels change over time. And what you're seeing is very, very, very little lumen depreciation. Essentially, you're looking at 90% into the mid to high 90% of lumen depreciation, which means what you get at the outset is very close to what you get at throughout 100,000 hours. And the red line is basically showing it at a lower drive current, and the green is at a higher drive current. Drive current does impact rated life a little bit, but again, you're still well above 90% in terms of maintained lumens. So this is a little bit nerdy, but it's kind of important for you to kind of understand, because this allows you to sort of see, okay, how do you compare apples to apples and not apples to kumquats? I talk a lot about 100,000 hours. What does 100,000 hours mean? So if you're looking at a dusk to dawn, and let's just say 12-hour burn time, that's 4,380, right, hours per year. So that's about 22 years. I don't know what everybody else thinks they're going to be doing in 22 years, but I don't picture myself relamping outdoor fixtures. I always picture myself on a beach somewhere with a cold beverage. So anyway, I digress. Stepping forward, if you look at what's happening with light levels over time, you can kind of see that LED just maintains their lumens better, which is really important. The next topic I want to touch on is, in addition to equivalency, uniformity is something else that we don't take into account as well as we should when we're thinking about LED technology. So I'll use an analogy of watering your lawn. Folks in California or wherever there's a drought, close your ears. This is forbidden, I'm sure. But, you know, when you think about watering a lawn, for example, is it better to just take your hose and just soak spots periodically, kind of like your image on the left, or is it better to take a sprinkler approach? And I think the analogy kind of holds true when you're thinking about exterior lighting. A lot of our HID, high intensity discharge sources, were these big point sources, right, where we ended up putting them in fixtures and using physics and reflectors and lots of acrobatics to direct the light where we need it. Contrast that to LED, which is kind of that bottom right-hand image where you're using smaller sources, you're aggregating smaller sources, and you're able to sprinkle the light. Sounds really stupid, but you're able to direct the light more precisely because you're not trying to bend a blob of light. You're essentially directing small rays of light where you need it, which allows you to be more efficient with the source, and it allows you to deliver light more uniformly, which really matters. So when we think about uniformity and how this sort of plays out, this is a typical kind of a plan view of a parking lot. And so when you look at LED lighting, the heat map that I'm showing here is really changes in maintained luminance. So what you're seeing is it's fairly, you can kind of see where your lights would be on your poles, but it's fairly uniform. Your average and your difference between your highest light levels and your lowest light levels, so max to min, that is still pretty good. When you look at, for example, HID lighting, you see these hot spots that are right directly underneath the pole. So those red, or the red is the hot spot. That's where a lot of people, your night shift nurses, a lot of people park there, by the way, because that's the brightest spot. But you see it completely drops off when you look at the spaces between the poles, and sometimes depending on your layout around the perimeter. So you can kind of see you've got high average to mins, high max to mins, high wattage, because you have a lot of that light right under the pole, but it's not really spreading it out very evenly. When you look at this visually, and I'll click through here so you can kind of see that. When you look at this visually, you recognize exactly what I'm talking about on the heat map. So this is a parking lot example where under the poles, and I hope you can see this well on your screens, you see those blobs of light. You see those hot spots. Sometimes they're shaded by the trees, but you see those hot spots in certain areas around that pole. And in this particular example, these were fixtures that were 250 watt metal halide, and so when you take that into account with your ballast, they were drawing almost 300 watts per fixture, and this is the before image. This parking lot was relit with LED, which instead of 300 watts, they were using 144 watts each. So automatically you get this savings of 50%. And there are some spots that you do see some higher light levels, but we kept the existing spaces in this relight example. So what happens at 2 a.m., right? It doesn't necessarily need to be that bright. So this is also showing, so on the left was the previous image where you've already got 50% savings because you've gone with 144 input watts. On the right, you see that it's now dimmed down to 45%. So you keep the uniformity, which is awesome. And uniformity improves people's perception of brightness anyway. If I've got lots of contrast, bright spots, dark spots, that's the problem. When I've got uniformity and I dim evenly, people do not recognize the change in light level. In fact, you could stand right underneath one of these poles and I could dim it down to 45% over 2 minutes, and you may not notice it. In fact, we do that all the time. This is what lighting nerds do for fun. But if at certain times of the night, for example, right, where nobody really should be in the parking lot, but you need it to be lit, you dim that down to 45%, you still have very good light levels. And now instead of 50% savings over your HID, now you're looking at close to 80% savings. So this is how control can really unlock more potential. Okay? So again, you're going from 295 to almost 300 input watts to 64. So that's pretty compelling. That's something that you could make a strong business case on. So just kind of comparing some of the different solutions, the first case was the HID lighting, and you could do different things, right? So you can go for equal light as the HID, which in many cases HID installations were overlit because of how the lamps would depreciate. And that's the solution on the right, where if you go with an equal light solution using LED, or you can go with a finesse solution, which means hit the light levels that are required and use only what you need, and you're able to save, in this particular scenario, 70% over the HID, $140 per fixture per year, 100,000 hours, which 22 years if you're thinking dusk to dawn. Here's another example of a retrofit, high-pressure sodium. If that's what you have in your parking lots or garages, you know this beautiful yellow light. Haha, kidding. And you can kind of see on the left where you've got kind of that monochromatic yellow light, which doesn't really do a great job of perception of the space or even facial modeling or recognition of colors or things like that, versus the after, which is kind of a better quality white light. This is another blowout of a similar installation where you can see the uniformity. So right below the pole, but then even between the poles, you're still seeing very, very good uniformity there. So stepping forward here, I'll go on to the third misconception, and then we'll talk about some of the choices that we have out there. So saving energy and reducing maintenance are the most important reasons to relight. Certainly those are those hard, quantitative business case items, right? Whether it's so hard costs that you can use to say, look, we really need to do this. But there are so many other reasons why we need to do a relight, and I think capturing those ahead of time gives you a better chance of getting a green light on your project, or really specifying what you need if you're thinking about an exterior relight. So what matters? You know, in addition to energy and maintenance, which is super important, I'm not discounting that, there are other things that we can address with a good exterior lighting renovation. So things like safety, so that's protecting people from things. Security, so that's protecting people and property from, you know, bad guys. Wayfinding, which is very important, illuminating your location, destination, how to get there. And then aesthetics. And aesthetics sounds like sort of this fluffy thing, but aesthetics matters, particularly in a healthcare facility. It's not just any other building, right? It is part of the community. It sends a message to your patients. It sends a message to supportive family members. It sends a message to your staff when you care to light your facility in the right way. So, we kind of talk, sometimes we use safety and security interchangeably. They're different. One is around sort of safe passage, and the other is safe from the bad guys, and we're going to talk about that separately. So when we think about safety, I showed another image of a high-pressure sodium versus an LED installation, and ideally this one kind of depicts it a little bit better. If you were concerned about, if you didn't know exactly where to step up on the sidewalk, right? On the right-hand image, you can clearly see, and you'd probably see it better if it was larger, the yellow, which identifies a change in grade, and it identifies the transition from the asphalt onto the sidewalk. On the left-hand side, you really wouldn't be able to pick that up unless you had like bionic vision. So color is kind of good because markings. A lot of times we're using color in healthcare facilities for wayfinding. Remember that you're on level 2, the blue floor. We use signage, but we also use color, and color helps if you have a light source that renders colors well, it improves those wayfinding aids. It also, the uniformity also matters. So this one, I'll ask you to kind of look at the left, which is an LED installation, and then look at the right, which is the existing HID. So essentially, this group said, I thought it was really smart. We're not going to do the whole parking lot. We're going to do a trial where we do half the parking lot LED so we can compare it to the HID. And automatically, you can see the differences in uniformity and how that would improve somebody's ability to say, okay, I can make safe passage from my car into the building. On the HID side, there are hot spots. It's a little bit gloomy. You wouldn't be confident that you could really traverse that lot safely, and that vehicles could see you effectively as well. So what about security? Does more light mean better security? Well, we're careful to say, light isn't of itself. There haven't been any studies that have explicitly linked higher levels of light to higher levels of security. I'd love to see them. But it's pretty well understood that lighting adds to the perception of security. So I guess the first bullet means that if somebody has criminal intent, that they have criminal intent, but light is a very effective deterrent, and it also makes people feel safer because they can see their surroundings. You also have a higher probability of detecting somebody that has criminal intent and, apprehending them as well. And so when we think about lighting for security, we're also concerned with, so in addition to lighting for safety, where we're thinking about the horizontal plane and maybe being able to walk on pavement, lighting for security, we think a lot more about vertical illumination, so being able to light up spaces well for facial recognition, or vehicles well for color recognition of vehicles. And you need to see details at greater distances when you're thinking about security lighting. When we think about creating a secure healthcare environment, certainly surveillance cameras are very prevalent in care facilities. Which increases the time that a perpetrator would need to commit a crime. And then we also use fences as well. And uniform lighting is really important when you have fences. You certainly don't want dark spots in your parking lot, for example, where you wouldn't detect somebody breaching a fence. So those are some things to kind of think about. When we talked about surveillance, and many of you are probably using surveillance image capture on your campuses, it really does make a difference when you're converting to LED. The images are generally a lot crisper. You can see the color of cars. You can make out faces a lot more easily with better lighting. And so if you look at this particular screen, you see metal halide on the left and then LED on the right. And this is a capture. It's not the same image, but it's simultaneous, where you're taking the north parking lot and the south parking lot. And as you can see, it's much easier to make out what's happening on the right than it is the left. So this is really, really important, and it's something that we, I think, don't talk about enough. Wayfinding is pretty straightforward. It's helping people kind of be oriented, understand, you know, where they need to go, where they are, where they need to go, and really a good, safe path to get there. In aesthetics, that's fairly straightforward, really kind of increasing the perception of quality, architectural features, historic features. I mean, many of our healthcare facilities have been around for 50, 100 years. Really playing that up is something that's really important for the community. So I've showed you a lot of reasons. I think we talked about 3 common misconceptions that we see all the time and ways that you can kind of maybe rethink those. In many of the before and after images, we showed selected solutions. And what I'd like to do is kind of really quickly step through some of the new choices that are out there for exterior lighting. And that to me, and I'll do this relatively quickly because it may be overwhelming, the number of choices, but that to me is the most exciting thing that we're seeing now is if you rewound to maybe even 3 years ago, you could have 1 or 2 choices, for example, to light a parking lot or to light a parking garage, and now you have multiple families that can achieve the same goal. That means for you that you're more apt to get exactly what you want when you're pursuing your project. So the right price point, the right lumen package, the right performance. So we'll step through here. In a couple of the images, I showed a product that comes from Lithonia Lighting called the D-Series. And this is a beauty shot of the D-Series. Look at it. How cute is it? 3 different sizes, different lumen packages. And it's not an orphan. It's part of a larger family where you have the area luminaires, wall pack for building facades, floods for things like signage and other applications, as well as parking garage and bollard lighting. So that gives you a nice uniform dayform visual experience. So everything kind of looks alike. So with the D-Series, you've got different sizes, and you're able to replace up to 1,000-watt metal halide when you're thinking about the largest size, the size 2. The DSX-0 is great if you have spaces where you want more pedestrian scale lighting, lower lumen packages, lower mounting height, so you don't want to blind people, you just want to provide the right amount of light on a pole. So lots of really good options. Really great. This is the flagship in terms of photometric performance. So you have precision lenses that are really directing light right where it's needed. And you have a lot of longevity in this system. We talked about that earlier. So 20 plus expected year service life with a lumen maintenance. So this is the difference between initial light level and what you would see at the end. But 91% of initial light at 100,000 hours, so you are not going to perceive that at all. The efficiency is really great because of the LED technology and the luminaire design, so you're able to save up to 90% over metal halide luminaires and a really nice, clean aesthetic. So that's the D-Series, and that family gives you lots of performance-driven options. There's a new family in town called the KAX. And there's 2 sizes of the area light. There's a KAX1 and a KAX2. So again, going up to 1,000-watt metal halide in the size 2, up to 400 watts in the size 1. And then there's also a wall pack so that you've got that nice complementary look. What's cool about the KAX, which is hot off the press, just launched, is that you've got a lot of nice features in there. So you certainly have universal mounting, and I'll talk to you why that's important. You've got thermally isolated drive compartment, and we'll spend some time on that. Field-Rotatable Optics. This is designed for smaller lots. So if, for example, if you've got a large parking lot and you really need a precision solution, in many cases the D-Series is going to be the way to go. But when you think about smaller campuses, say it's an off-site or a satellite clinic or a smaller area where you need parking lot lighting, the KAX is really nice because its form and its forward throw really allows you to put these at the perimeter and to light applications really easily. So I'll show you some of this so it makes sense about what to use when. The KAX is great. You're looking at still great efficiency, about 70% energy savings over metal halide. Efficacy is up to 148 lumens per watt, which unlocks DLC premium rebates and lots of other features that we just kind of talked about. I won't belabor that too much. So again, this kind of just spells out some of the lumen packages. You can get more information on that later, but you're going from 6,000 lumens all the way up to 32,000 lumens, so tons of different options there. There's a lumen package that meets your needs. If you look at comparisons, essentially, for example, if I were trying to replace, think about that parking example a few slides back, 250 watt pole mounted luminaires. I could use a 96 watt luminaire, which saves me about 70% energy, and that's $104 per fixture if I'm thinking dusk to dawn operation and 12 cents per kilowatt hour. I am not considering the fact that I could unlock even more savings and probably save an additional 50% if I used integrated controls and I dimmed it down to, say, 50% at certain portions of the night. So that's just luminaire to luminaire, but don't forget the controls. The universal mounting is really, really important. So the KAX comes standard with an integral universal mounting feature. So that allows you not to have to figure out what you have, what's the drill pattern, should I really drill into this older pole. It really allows you to just specify this fixture and be able to mount this on any fixture without having to drill, whether you have a square pole or a round pole. Field-Rotatable Optics is kind of nice too. At the job site, sometimes you get a luminaire and you install it on your campus, and the position is not quite right. What this allows you to do is really mistake-proof some of your installation. So if you want to direct the light a little bit, the Field-Rotatable Optics allow you to move the light engine 90 degrees to the right or the left. So this kind of simplifies things if you really want to have some better directionality. In addition to the rotatable optics, you also have a tilt option, which allows you to tilt the light engine up to 80 degrees. Now, you want to be careful about not directing it into areas where an oncoming vehicle would be looking at the luminaire, so you don't want to sort of create any glare in that case. But sometimes you want to subtly increase that forward throw. So this is a really nice option. It's called the tilt option. So that, in addition to the rotatable option, you can have both of them. That allows you to mistake-proof any installation. Cool driver is happy driver. So when you look at kind of this orange here, that's the light engine. And when you look at this blue-green, the driver is in that compartment. So in many cases, even if you looked at this a couple years ago, people would say, look, the driver's going to fail. You don't have fixtures that are going to last 100,000 hours. And heat was really kind of a major failure point for a driver. So by thermally isolating that driver and having really good heat sinking technology, it really does ensure that you have a very long driver life, which translates into a long system life. This is just showing a motion sensor option. All of the luminaires that I'll show have integrated motion sensor option, where you can choose the sensor that you need depending on your mounting height. And you can enable lower levels during dusk to dawn operation. I'll show you kind of what this would look like. So for example, you would have a minimum light level and a max light level. So what this would mean is that at night, your lights would come on at a minimum light level. And then when motion is detected, you would see them slowly ramp up. So 3 seconds, so not too slow but not too fast. You're not going to scare anybody, so that it goes up to full brightness. And it stays that way until 5 minutes after that motion is sensed, right? And you're using a passive infrared sensor, and it goes back to that minimum level. So that's nice in certain areas. So it may not be something that you use in, say, main entrance lots, but if you've got perimeter lots or if you've got top level parking decks, you're still going to have good sufficient light even at the minimum level, but why not save the energy and just ramp it up when you need it, not necessarily keeping it on bright all the time in case you need it. So this is kind of what we talked about before in terms of the positioning. The KAX is very aggressively priced, so it has a really strong payback. D-Series is also very competitive. It's your performance leader. Use the KAX in smaller parking lots. And the D-Series, if you've got larger open spaces where you really want to optimize for uniformity. You certainly have more lumen package options in the D-Series, but the KAX does kind of give you what you need. 3 photometric distributions for the KAX, so fewer than the D-Series, which gives you 14. So the D-Series is your precision tool. The KAX is kind of a good, solid performer. Lots of great options with each of those. The KAD LED comes in a complete fixture as well as just a retrofit door if you already have a KAD from Lithonia Lighting, which is one of the best-selling outdoor luminaires ever. This gives you more of a traditional form. So certainly you are able to have that shoebox style and that familiar design, but we didn't just throw LEDs into an old form. We have definitely optimized with high-performance LED light engines, integrated sensor options. You can do bi-level as well as part-night onboard controls, and again, you have that 20-year service life. So lots of options there with the KAD LED, and it meets legislative requirements like California Title 24, so lots of different options there. Wall packs. Wall packs are fun to talk about. You know, when you look at the TWH and the TWP, which are essentially kind of polycarbonate and glass wall packs, TWH is glass, TWP is the polycarbonate. This is, again, a familiar design, but it's been optimized for LED. And I'll show you some images here. I'll show you kind of what's different. So you've got that classic day form, but there's a lot of technology. So you've got, in many cases, you'll be replacing a fixture that looks just like this. So we've kept a lot of the housing details the same. Certainly you could go with a sleeker wall pack. Sometimes people don't paint behind fixtures that are already installed on a wall, so you sometimes have paint lines and things like that that you want to cover up. So that's the argument for having a fixture that looks very similar to the HID version of that. So you've got really great performance through individual optics that are delivering the light right where it's needed, so there's no blob of light here. Here's an installation where you were using 400-watt wall packs, and you gotta love the color shift here. It's sort of a kaleidoscope of color. I like that greenish hue. Green's one of my favorite colors. But if you compare the 460 watts in per fixture to 105 watts in per fixture and just that beautiful uniformity, gotta give it to you again because that was really nice. You can kind of see what this does to its space. So your building facade, the sidewalks around the building, it's just better illumination. Let's move to parking garages really quickly. That is the low-hangingness of low-hanging fruit. I just made up a word there. The PGX is a product that has been out for a couple of months now. Really great performance, really great visual comfort. We know that sometimes in certain mounting heights, parking garage, LED parking garage luminaires can be just a little bit too bright. The PGX solves that problem by combining form and function and making sure that the light is very kind to the eye. You still get the great energy savings, so energy savings of up to 86% when you're comparing it to, say, a 175-watt metal halide. And again, you're looking at 100,000 hours. This is 12-plus years because we're assuming 24 hours of operation every single day. That's very typical in a parking garage. You can do standalone controls where it's embedded in the fixture, or you can network them. And there's some good arguments for using network controls in parking garage applications, and I'll kind of talk about that as well. So this is just an example where you would be comparing a PGX to a 175-watt metal halide, looking at 210 input watts for the metal halide, energy savings of $1,800 a year, lamp change cost of $320 a year, ballast change cost of $100 a year. So you've got over the 10-year life. So you've got 10-year total operating cost for Luminaire of $2,260. Compare that to different lumen packages in the PGX, and you see that you are basically, with the first option, the 30 watt, it's a tenth of what that cost would be. So your 10-year savings really does add up, and your annual savings certainly adds up as well. So this is an area where you should be able to get really great total cost of ownership, reduce that dramatically, and get really good payback. This is just showing a comparison between integrated sensors. Again, we talk about by level. So at 2 a.m., what should your parking garage fixtures do? The integrated sensor, it means that basically the smart is in each fixture, and it'll control separately. The option to the right is XPoint Wireless, which is networked. So you're able to control a group of fixtures in concert. So you can bring up a zone of lights at the same time, as opposed to individual lights maybe changing intensity separately. There's some benefits to having networked zoned controls. It sometimes gives you sort of a safer feel. Plus you can do things like schedule light levels and demand response dimming. And lastly, and I'll just kind of wrap up here, the last option is the D-Series parking garage, which many of you may have seen. Lots of flexibility here. Again, this is your precision tool. You're able to get really aggressive paybacks on the D-Series. Lots of different distributions here, which allow you to light a parking garage based on your layout and where your mounting points are. So you're creating really superior uniformity because you're directing the light exactly where you need it. So lots of choices there. Here's an installation where you're seeing kind of a 37 watt fixture, really nice, crisp light, really good uniformity. Here's another installation. This is Tishman's Fair in Newark, New Jersey. Really beautiful uniformity there. So in terms of the product offering for parking garages, you've got, for lower mounting heights, you've got very cost-competitive solutions, you've got visually comfortable solutions, and then you've got your precision tool, your high-performance solutions. So lots of choices across the board. So in conclusion, I know that was a lot. Lots of choices. I hope you can kind of appreciate that. If you haven't looked at exterior relight opportunities, you know, the options today, I hope that I showed you something that you didn't know, because it's really changing at a rapid pace. Outdoor is a really great place to start, minimally disruptive for healthcare, and it can help pay for other campus upgrades. And across the board, there's no reason you shouldn't find the perfect solution for your campus through any reputable manufacturer if you're interested in pursuing an exterior relight project. So with that, I will turn it back over to the moderator. If you want to learn more, there's some information on the screen, and I'll turn it back over to the moderator for questions.
Thanks, Karen. Yeah, that was a great presentation. Thank you for taking the time to spend with us. We do have a couple questions in the queue here, and if you do have a question, feel free to type it in the Q&A box and send it over to us so we can get Karen to share some knowledge with us. So here's one. Karen, this is from kind of the beginning of your presentation. What did you mean when you said $1 saved on the bottom line means 50 on the top line at the 2% margin?
Yeah, no, it's just me doing math on the fly. Essentially, which I shouldn't do that in public. Essentially, if you've got a 2% operating margin, that means that it's 2% of every dollar that really does drop to that bottom line. So I just did reverse math to say $50 on the top line would equal $1 on the bottom line if you're looking at a 2% operating margin, which is the average operating margin for a not-for-profit hospital. Now, for the investor-owned folks, they're looking at somewhere between 4 and 5%, but it's still not a lot of money.
Okay, great. Thanks for clearing that up. Here's one. What is the effect of LED on urban sky glow?
Well, see, we should have a 3-hour webinar. Then I could talk about bug ratings, backlight and uplight and glare. There's so much to talk about. If you haven't heard of it, look up the model lighting ordinance. It takes the idea of dark skies even further. And essentially, every outdoor luminaire gets what you call a bug rating, which isn't what you think it is. It really stands for, it's an acronym that stands for backlight, uplight, and glare. And the model lighting ordinance and the bug rating ensures that light is directed where it needs to be, so that you're not looking at a lot of light spill behind, above, which is really what's sort of creating kind of that light spill in urban skies. But it also doesn't give you too much glare either. So ask your manufacturers about bug ratings. This is a really important thing that helps ensure that the nighttime skies, you can kind of see the stars, maybe. And who wants to pay for light that's lighting the atmosphere, right? You paid for parking lot lighting. You didn't pay for that. So think about bug ratings and model lighting ordinance.
Okay, great. Thank you. I wanted to give everyone on the call the opportunity, as you're looking through doing a process for a relighting on a healthcare facility, Graybar's got a great guide out there that kind of takes you through the whole process. So if you're interested in receiving that guide, we can send it to you. Just type in guide, G-U-I-D-E, into the Q&A box, and we will send that your way. Another question here. Are dimmable drivers standard in the KAX, KAD, and D series fixtures, Karen?
I knew somebody was going to stump me. I believe dimming is an option. But I need to confirm that if they're standard across those families. I apologize. I should know the answer. I believe that dimming is an option because you're able to then specify what type of dimming, if it's part night or bi-level or whatever it is. It does vary sometimes across the families. The LED drivers are designed to dim very easily, so it really shouldn't be a problem. In fact, we encourage it. That's how you maximize your savings.
All right, let's do one more question. How do wavelengths of light from LED compare to HID lights?
Oh man, this is another thing I should have done. Spectral power distribution. That is like lighting nerd jam. That's my jam. So it's different. It's completely different. So everybody, I don't know if the folks on the call ever heard of Roy G. Biv. So we know that the visible light, so light, there's a visible portion of the spectrum that we see, and we've got short wavelengths, which are kind of blue, indigo, violet, but all the way to the other side of the spectrum, which is red, orange, and yellow, and of course green is in the middle. So it depends on your HID source. Certainly when I was showing shots of high-pressure sodium, what you see with high-pressure sodium, and I'll definitely, if you guys are SPD nerds, I can send you this, is you see this huge spike at the yellow. And there's not a lot of energy anywhere else. And that's why red cars look brown under high-pressure sodium lamps, because if there's no energy in that color in the light source, there's zero possibility that you're going to depict it on your task. Certainly when you get to metal halide and ceramic metal halide, color-optimized white light, you get more energy across the spectrum, but LED actually, and all LEDs aren't created equal, but LED lighting generally does a better job of depicting colors because you have more of a continuous spectrum and you have more energy in the various wavelengths. And I can send you some comparison spectral power distributions. You also have more color temperature choices, and so just a note, for example, in many cases you can get with some of the Lithonia products 3000K, which is kind of a warmer light, to a 5000K, which is a crisper light. Colors will present differently underneath those different color temperatures. So the crisper light will make your blues pop a little bit more, where the warmer light may make your reds and oranges more prominent. That's just, you can notice that phenomenon in your living room too. So just a note there. Generally, it should be better. LED doesn't have UV, so it also doesn't attract certain bugs that you would get with some of the traditional sources. So that's a bonus.
Okay, great. Thank you, Karen. A lot of great information there. Unfortunately, we are out of time, so if I didn't get to your question, we will follow up with you after the presentation. Just a reminder to everybody, this presentation will be archived on graybar.com, so you can watch it again or share it with your friends. So once again, thanks for your time today, and we hope that you will join us next time for a Graybar G2 Talk. Thanks again, Karen.
Thank you. Thank you so much for the opportunity. Thanks, everybody.